Welcome children for the next episode. Today we are going to discuss about potential energy. In our previous class we discussed some terms from this unit. One is about work. Work is the force into displacement. Work is measured as the product of force and displacement. To do work, these two quantities required. One is force and another one is displacement. Among these, any one of the quantities not there, then there is no work. Then we discuss also about the unit of work, joule, and also about how much is 1 joule of work. Then we discuss about kinetic energy. Then we say E, K. E is for energy and K for kinetic. And we can measure by using the relation half mv square, which is the relation used half mv square to find kinetic energy. Now we want to discuss about potential energy. Potential energy. See here, this is a rubber band. I am stretching this and release. What happens? This occur its original. See, when I pull it, it elongates. But when release, what happened? This come to its original position. To change this, what does I do here? I does work. That means to change its length, I does work here. In the same way, see, this is a slingy. See, this is a slingy, and see, this one is placed here. I pulled it to this one, to this side. And when I release this one, what happened? I pulled it to, after one end of this one is held in this hand and pulled it to this one. See, pulling here means I do work. And when I release this one, see, when pulling to this side, it elongates, and when I release here, see, this one comes to its original condition. What happened in these two cases? See, to elongate the rubber band, I do certain amount of work. I do certain amount of work here. And that work change the shape of that rubber band. Change the shape, or it produces strain in it. Change the shape, otherwise it is called produces strain. Due to the work in the rubber band and also in the slingy, what happened there? There produced strain. And when I released it, the work there produced as strain changes in its shape, and after it attains its original condition. That means the work here done is what is that means to produce strain or to change its shape, and the energy stored there. Due to the work, there stored energy. Due to work, there stored energy, and this energy is actually give the reason to return its original condition. And here the question that asked to you, how did it acquire energy when stretched? That means when the rubber band is stretched, how did it acquire energy when stretched? Due to our work, it acquired energy, or it produced their energy due to what is strain. Because of that, it returns to its original condition. When I pulled the slingy, what happened? Its shape changed, or they produced strain. How did the slingy acquire energy when stretched? Due to the work which I did. Once again, how did the slingy acquire energy when I stretched? When I stretched, I do certain amount of work on it, and that work converted as energy in it. That work converted as energy in it. Would the slingy acquire energy when it is compressed? See, if this case, if it elongate and articulate, that means here. See, here compressed, and I release, see, it again returns to, see, here it is compressed, and I release, see, its original condition, it will attain. That means when this slingy is compressed, then also it acquires energy. And this kind of energy that here stored or produced due to strain or change of shape is also called what is potential energy. Here energy that body got due to the strain is called what is energy due to potential. Energy due to potential. We know there are two types of mechanical energy. One is kinetic energy and another one is potential energy. Here the slingy or rubber band attained energy. Which energy? Potential energy due to the strain. How that energy is there? It is due to certain amount of work that I did on it. Now see, if we consider the case of a toy car. If we consider the case of a toy car, when I wind the key, that means when I wind that means turn the key of the toy car, the spring in it wind, and when I release, what happened to it? It moves forward. How the car, how the toy car got energy? The toy car got the energy due to what is a strain. That strain created in it stored energy in the form of potential. Now we consider, suppose on body is lifted to a certain height. Suppose this scale I am lifting to this height. For this also I want to do certain amount of work. That means from this level to lift it to here. For that a certain amount of work I should do here. If I release this, this scale will come down. The work done here, suppose a body is lifted, a body of mass M is lifted to a height h. Consider a body of mass M. Body or object of mass M. Lifted to a height h. Here, for it, I want to work. We know, work done to lift this object from here to a height h. We can calculate it by using the relation work is equal to what? Force into displacement. See, here we took the body of mass here. So the work here, we know force into displacement. Force here is the gravitational force, that means a body of mass M in its gravitational force is mg. In its gravitational force acting is mg. To lift this body of weight mg, we should apply an equal amount of force in the upward. So here the upward force, that means upward force applied, F is equal to mg, which is equal to the gravitational force or weight of the body which is acting downward. We know work done is equal to force into displacement. So work is equal to here, force is mg. Then what is the another term here? It is displacement. Displacement is how much here? Here it is h. So the work done here is that is W is equal to mgh. If this body is at this position, so for example, I will take stone of mass mg to a mass mg m. For example, I lift a body of mass m to a height h. Then its weight is mg, mass is m, and here that is work is done. When this body is reaching at this point, it has got the ability then to do work. That means that body now possesses energy when it is at this point. And that energy is due to the work which I did here. And here the energy is due to its height or position. Here this energy is due to the position, because of that it can do work. And that energy is also called what is potential energy. So object can attain potential energy due to its shape change, otherwise it is called strain, and also due to position. So body or an object can possess energy in which energy? Potential energy in two different cases. One is what is due to the change of position, another one is due to strain. So potential energy is the energy possessed by a body or an object due to its position or state of strain, due to the position or state of strain. Similarly is the case of what is a bow. When we consider a bow and when we pulled an arrow in it, what happened? That bow acquire energy due to strain. And when we release the arrow, it moves forward due to potential energy, and here the potential energy due to strain. So in which cases a body or an object can possess potential energy, one due to its position, another due to the state of strain. Here you see the work done W is equal to mgh. This work now stored in the form of energy, and it is called what is potential energy. That is EP. E is for energy, P for potential. So potential energy is equal to mgh. A body at a height h from the surface of the earth, how much potential energy it possesses? It possesses EP is equal to mgh. That much potential energy it possesses. So we got another relation to calculate potential energy. Before we got the relation how to calculate kinetic energy. Now to potential energy, EP is equal to mgh. Now see here. some numerical problems given to you solve. Find the energy possessed by an object of masses 10 kg when it is at a height of 6 meter above the ground given g is equal to 9.8 meter per second square. Find the energy possessed by an object of mass 10 kg. Mass of the body. At a height of 6 meter. Then given g is equal to 9.8. G is equal to 9.8 meter per second square. What do you want to calculate? Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meter above the ground given g is equal to 9.8 meter per second square. Now, see, we know the relation to calculate potential energy is equal to Hmcs. So, potential energy, first of all, the relation EP is equal to mgh. That is equal to m here is given as 10 and g 9.8, h is 6. Now 9.8 into 6. 6 times 8, 48. Balance 4. 6 times 9, 54 and 58. See, then there is some decimal. Putting here. How much it will? 588 joule. 588 joule is the potential energy of that object of mass 10 kilogram at a height of 6 meter above the ground. See, one thing here you want to remember. Let this body is taken from ground level. This body of mass 10 kilogram is taken from here. This height is 6 meter. And directly I took it from this ground to this top, this 6 meter height. And now it is at a height of 6 meter and its mass is 10 kg. I calculated potential energy and which I got 588 joule. Suppose if the body is taken in another way. That means at first I took here suppose 2 meter, then to here, then to here, then this way to same height. See, here also 1.5 and 2.5. Now the total height is 6 meter itself. That's the work done in these two cases. Different means here the work done against the gravitational force in these two cases same. Here also, in this case also, we did certain amount of work against gravitational force and we calculated it as 588 joule. When we calculated work done against the gravitational force in this case also we get it is 588 joule itself. So work done against gravitational force in these two cases will remain the same. So the potential energy also same. So the potential energy depends only the height, not the path through which it is taken. That is from here this to east. What is the factor that depends on potential energy here? Or in the case of position, it depends only the height from the earth surface. That means not the path but the height only it depends. That you want to remember. Now there is another one problem given. See, an object of mass 12 kg is at a certain height above the ground. If the potential energy of the object is 480 joule, find the height at which the object is with respect to the ground. Given G is equal to 10 meter per second square. An object of mass 12 kg. Mass is given. At a certain height above the ground. At a certain height. That means at what height it is not given. 480 joule. If the potential energy of the object is equal to 480 joule. Find the height at which the object is with respect to the ground. We want to find out the height from the surface of the earth or from the ground. And here given G is equal to 10 meter per second square. 10 meter per second square. See, here we know the relation potential energy EP is equal to Mgh. We can put the given values in this relation. EP is given 480 is equal to M. It is given as 12 and G10 into H that we know, which we want to find out. From this relation, H is equal to 480 divided by 12 into 10. We can cancel all at 0. Now 48 by 12. We know in 48, 12. 4, that means 4 times 12 is 48. 4 times 12 is 48. So this will come as 4. So height of that object is, that object is placed at a height of 4 meter. That object is placed at a height of how much? 4 meter. This is the height of that means height at which that object is placed. Not height of the object, height at which that object is placed is how much? It is 4 meter. Now, we know there are different forms of energies. We want to know, is it possible to convert one form of energy to other forms? For example, take the case of electrical energy. In an electric ball, happens to the electrical energy given to it? A part of it converted into light. There also produce a certain amount of heat. So, an electric bulb which consumes electrical energy changes to light and heat. In the case of an electric fan, see, there also we given electrical energy. What happens to that energy? Electric fan converts that electrical energy into mechanical energy. Mainly it converts as mechanical energy, then there also produce very small amount of heat. So one form of energy here is converting to, one form of energy means here electrical energy is converting to mechanical, here electrical energy is converting to light and heat. When we consider the case of solar energy, when we consider the case of solar energy, green plants convert it into stars. In the presence of solar energy or light energy only, green plants can do the process called photosynthesis. That means they are producing what? Stars. And when we consider the case of electrical energy, another way appliance that you can remember, here we see electric bulb, fan, for example TV. There also it produces different forms of electrical energy, which are the one it is producing light, then sound, then a small amount of heat. In an electric heater, see, electrical energy converted into heat. Then laundry iron, they are also produce heat. See, here are one form of energy changes to different other forms. That means energy we can change from one form to many other forms. But energy neither be created nor destroyed. Energy neither created nor destroyed. But what actually we do? We convert one form of energy to many other forms. Only what we can do, we can convert one form of energy to other forms, but we cannot create energy or we cannot destroy energy. This is called what is actually law of conservation of energy. Law of conservation of energy. To prove this, we can take the case of a stone which is placed at a height of h. See, a stone of massive and is at a height h. From this is ground. Now it is placed at this height. See, this stone, its mass is m. How much is the energy possessed? Here the energy possessed is potential. So, potential energy at this point is equal to mgh. That is force acting mg and height h, mgh. And the kinetic energy here, how much this stone is at rest here. Kinetic energy is the energy possessed by an object when it is under motion. Moving body only possesses kinetic energy. So the kinetic energy at this point is 0. Hence the total energy, that is the total energy, is equal to EP plus EK. That is mgh plus 0, mgh. When the stone starts to fall, its height decreases. At the same time, its velocity increases. Velocity is going up and height is going down. Then what happens when the height decreases? Its potential energy decreases. What happens? Its speed or velocity increases, its kinetic energy increases. So the total energy at any point here is what is E potential energy plus E K kinetic energy. Suppose here its potential energy is reduced, decreased. At the same time, kinetic energy is increased. So the total energy, that is EP is plus EK is same as what is mgh. When the stone is just going to touch the ground, just going to touch the ground. When the stone after falling here comes to the ground and it is going to touch the ground, then its height become what is 0. That means when the stone is just going to touch the ground, its height becomes 0. And kinetic energy then it becomes that means maximum. Kinetic energy there becomes maximum and it is equal to, that is half of v square here becomes equal to what is mgh. So the total energy is the sum of potential and kinetic energy, and it will be same everywhere. That means at the top it will be mgh, and at any point in between the top and between the ground it is also mgh, and when that one is just going to touch the ground, then also it is mgh. That means the total energy is a constant. That means here the total energy, what is mgh plus half mv square is equal to a constant. That means the total energy is not changing. Total energy is not changing, that will be a constant. This is actually what is we getting from law of conservation of energy. That means we can convert one form of energy to other forms, but energy neither created nor destroyed. See, with this here on question is given, we can solve it. An object of mass 20 kg is dropped from a height of 4 meters. Fill in the blanks in the following table and table by computing potential energy and kinetic energy in each case. At first, see, it we want to calculate at a height of 4 meters. That means potential energy is equal to mgh, m 20 G we can take approximately 10 into Gx 4. That is 800 joule. The value of G here we took as 10 meter per second square. And the kinetic energy at this point, kinetic energy is Ek is equal to 0. So the total energy is sum of these two, that is 800 joule inside. That is at the height 4 meter, total energy at the height 4 meter, total energy is how much? It is 800 joule. Now we want to find out at a height of 3 meter how much is its potential and kinetic. See, at a height of 3 meter potential energy is equal to Mgx, that is 20 into G 10 into H3, that is equal to 600 joule. That means this stone fell to a distance of 1 meter from here. That means the displacement is equal to 1 meter. And its initial velocity is 0 there. So 2as or 2gs is equal to v square minus u square. From this 2 into a is 10 into s, it travels 1 meter on is equal to v square. That is equal to v square is equal to 20. So we can find out kinetic energy half. That means Ek is equal to half m v square is equal to half into m 20 into v square is how much here? 20. This we can cancel 10. So this will come as how much? 10 into 20 is 200 joule. That means at a height of 3 meter, its kinetic energy is 200 joule. So the total energy is equal to how much? 600 plus 200. That is equal to 800 joule. That means at the top it is 800 joule. At a height of 3 meter, its total energy is 800 joule. Now the question is at a height of how much? 2 meter. 2 meter potential energy we can calculate it. Here it is 2. That is P is equal to mgh. P is equal to mgh, that is 20 into 10 into 2. That is 2 into 4, that is 400 joule. This is the potential energy at a height of 2 meter. Then its kinetic energy, that means it travels to a distance of 2 meter from here. So 2 into 10 into SL2 is equal to v square. So 2 into 2 4, that is 4t is equal to v square. Now we can calculate half of v square. Ek is equal to half m, that is 20 into v square, that means 40. We can cancel to get 10. That is 400 joule. See, potential energy there is 400 and kinetic energy is 400. So the total energy there is equal to how much? 400 plus 400, it will come as 800. It is 800. Now we want to find out at a height of 1 meter. Then when the height is 1 meter, potential energy is equal to mgh, that is 1. Then how much it will be? It will be that means 200 joule. Then kinetic energy, that means from the relation 2AS is equal to V square minus U square. That means 2 into A is 10 into S 3 meter it traveled into V square. So this becomes how much? 6 into 10, 60 meter per second. Meter square, second square is V square. So kinetic energy K is equal to EK is equal to half M. Yeah, M is 20 into V square 60. That is equal to 600 joule. Here also total energy, that is potential 200 plus kinetic energy, 600 total energy is equal to how much? 800. 800 joule. Now, lastly, we want to find out just above the ground. Just above the ground means there is no height. There is no height means potential energy becomes there 0. Potential energy becomes 0. Kinetic energy to calculate we want to find out V. So 2AS is equal to V square minus U square. 2 into A10 into S traveled at a distance of 4 meter is equal to V square. 2 into 4 8, that is 80. V square is equal to 80. Now EK kinetic energy is equal to half M V square, that is equal to half into M 20 into V square 80. That by cancel this 10, 800 joule. So total energy is 0 plus 800, that is equal to 800 joule itself. So the total energy at any point will remain same. Okay. Today we discuss about the different forms of potential energy. That means potential energy can attain due to its position and also due to strain, and total energy and law conservation of energy. With this all we can conclude today's class. Okay, thank you.